3229. Which condition is most favorable to the development of carburetor icing? A. Any temperature below freezing and a relative humidity of less than 50%. B. Temperature between 32 and 500 degrees Fahrenheit and low humidity. C. Temperature between 20 and 700 degrees Fahrenheit and high humidity. The correct answer is C. The condition most favorable to the development of carburetor icing is a temperature between 20 and 78 degrees F and high humidity. Carburetor icing occurs when the temperature and humidity conditions are conducive to ice formation within the carburetor. In this temperature range, moisture in the air can condense and freeze on the internal surfaces of the carburetor, leading to a restriction in the fuel flow and potentially causing engine performance issues. High humidity provides the moisture necessary for carburetor icing to occur. 3230. The possibility of carburetor icing exists even when the ambient air temperature is as A. High as 700 degrees Fahrenheit and the relative humidity is high. B. High as 950 degrees Fahrenheit and there is visible moisture. C. Low as 0 degrees Fahrenheit and the relative humidity is high. The correct answer is A. When the temperature ranges between -7 degrees Celsius, 20 degrees Fahrenheit, and 21 degrees Celsius, 70 degrees Fahrenheit, and there is visible moisture or high humidity, pilots should remain vigilant for the potential formation of carburetor ice. These conditions are conducive to ice formation within the carburetor, which can disrupt the fuel-air mixture and lead to engine performance issues. Even if the temperature is above freezing, the presence of moisture in the air can still contribute to carburetor icing. Therefore, pilots should be alert and prepared to apply carburetor heat or take other appropriate measures to prevent or mitigate the effects of carburetor ice during flight. Regular monitoring and awareness of temperature and humidity conditions are essential for maintaining safe engine operation. 3230-1. Carburetor icing can occur with an OAT as high as A. 1000 degrees Fahrenheit and visible moisture. B. 200 degrees Celsius and high relative humidity. C. 750 degrees Fahrenheit and low relative humidity. The correct answer is B. Pilots should maintain a constant state of alertness for the possibility of carburetor ice when the temperature ranges between -7 degrees Celsius, 20 degrees Fahrenheit, and 21 degrees Celsius, 70 degrees Fahrenheit, and there is visible moisture or high humidity in the air. These conditions create a favorable environment for the formation of carburetor ice, which can disrupt the proper fuel-air mixture and result in engine performance issues. Even though the temperature might not be below freezing, the presence of moisture in the air can still lead to carburetor icing. Therefore, pilots must remain vigilant and ready to apply carburetor heat or take other appropriate actions to prevent or address the effects of carburetor ice during flight. Regular monitoring of temperature and humidity conditions is crucial to ensure the safe operation of the engine. 3232. Applying carburetor heat will A. Result in more air going through the carburetor. B. Enrich the fuel/air mixture. C. Not affect the fuel/air mixture. The correct answer is B. Applying carburetor heat will enrich the fuel/air mixture. Carburetor heat is used to prevent or remove carburetor ice by introducing warm air into the carburetor. This warm air helps to melt any ice that may have formed and improves the fuel/air mixture by adding additional heat energy. The enriched mixture compensates for the potential loss of fuel flow due to ice blockage and ensures proper combustion and engine performance. 3233. What change occurs in the fuel/air mixture when carburetor heat is applied? A. A decrease in RPM results from the lean mixture. B. The fuel/air mixture becomes richer. C. The fuel/air mixture becomes leaner. The correct answer is B. When carburetor heat is applied, the fuel/air mixture becomes richer. Carburetor heat introduces warm air into the carburetor, and this warm air reduces the density of the incoming air. As a result, the fuel/air ratio becomes richer as there is a higher proportion of fuel relative to the decreased density of the air. This adjustment compensates for the potential loss of fuel due to carburetor icing and helps to maintain proper engine operation.